Good afternoon, class. Now we're going to do a mini lesson on constructing a field map. Now we did this in lab yesterday, but making isolines and isotherms can be a complicated topic, so we're going to go over this one more time in class. So, as a brief review, going over how to construct a field map. Okay, this is a picture just of a field. It's just an area. It can be as big as a large universe or as small as a rock. It could be pretty much anything, but this is to give you an idea that anything can be a field. Okay, we can measure the temperature at different points in the field. We can measure rainfall, intensity of sunlight, or the volume of sound. There is no end to the things that can be measured as long as they are measured accurately and with a reliable instrument. At the top left we have a thermometer, then we have a picture of sunlight. At the bottom right hand corner we have a picture of a rain gauge. These are instruments that we use on a daily basis to get valuable meteorological information that we use to construct weather forecast, climatology, things like that. Okay, now if we want to measure the depth of the snow at various points in the field, what do we need to do? First, we would have to send out people into the field at different places to find out where we want to take measurements. That's very important. We just don't want to rely on one point to take one measurement. We need to get a variety to see what goes on and to not have the data be skewed. Then we would record each measurement and put it on a field map. Now, in this case, we're measuring the snow depth in centimeters. Very important to use units and to make clear what units you're using. Okay, here we have a plot of a snow depth map. Different points along the area, people measured probably with a ruler how deep the snow was. So each value represents the actual depth of the snow at the location in the real field. The next thing we need to do is to draw lines connecting points of equal value. Okay, so in this case, we are going to be using isolines. Iso is a prefix meaning equal, so lines that connect equal value are called isolines. Later we're going to be discussing isotherms, where therms means temperature, so those are lines of constant temperature. Okay, before we start drawing we have to do two things. First, there are several numbers and we do not want to draw lines for all of them. We need to have an interval of a specific value that we make sure we follow the plot. We don't want to plot every single number because your maps are just going to get too complicated and too messy. So let's determine what we're going to use as an interval. In this case, we have values ranging from 13 to 44, so let's use an interval of 5 centimeters. Okay, the first thing we have to do is to plan out our route. So drawing isolines is a lot like planning a long road trip. You don't want to just get in the car and start driving. You need to make a plan and map out your procedure so we don't have any complications along the way. Okay, so first, since we're starting at 13, it makes sense to start at 15. Then we'll do 20, 25, etc. So here we have several values of 15, 20, and 25, so we're just going to draw the lines as best you can. Nothing's perfect on an isoline map, so do the best you can. Alright, so now that we have 15, 20, and 25 plotted, next is 30. But we don't have any specific 30 centimeter points. So now what we have to do is estimate. So grab your numbers and we're going to try to find where 30 would fall on this particular map. So on the left hand side we have 28 and 31, so 30 would be roughly in the middle. Okay, so let's move to the right. We have 27 and 32. Plot 30 roughly in the middle also. Okay, so this is our starting point. We need to make dots if they're not already there. Okay, so same thing. Move on up the graph and find two more points where you can find roughly 30 centimeters where that would fit. Alright, so now we have our isolines plotted. 35 was relatively easy, as was 40. Okay, next question. Should we draw a 45 centimeter line? The answer is no, because we do not have a physical value of 45. We have values reaching up to 44, but on this particular map, there's no reason to put a 45 contour line because it just does not exist in this case. So this map is correct the way it is. If there was a 45 degree centimeter reading, then we would plot a little line, but it's not necessary on this map. Okay. Are there times when the isolines don't extend to the edges of the field? Yes. Now look at the values on this pressure map. These represent air pressure measured in units called millibars. The lines used in these air pressure maps are called isobars. Isobar means pressure. Therefore, we use isobars before we use isolines. Okay, with practice, you're going to learn how to recognize isolines that form closed paths and others that extend to edges. So all we need to do is practice, and we're going to have a couple more labs that deal with making contour maps shortly. Okay, so what is the value of point A on this map? A is greater than 972, but is less than 976. However, it's closer to 976, so we can probably assume that point A is about 975. What is the lowest possible value to the nearest whole number of point X? This map interval is 4. There is no 968 isoline, so X must be less than 972, but more than 968. So we'll say the lowest value of X is 969. Alright, what's wrong with this picture? It's pretty simple because we've discussed this several times. Isolines cannot cross. Very important. If you have crossing lines, then you did something wrong. Okay? If lines are crossed, then where they would intersect would have two values at the same time, which is impossible. So on this diagram, where you have the black arrows pointing where the lines intersect, you would have a pressure of 976 and 980 at the same instant, and that is absolutely impossible. So that's an easy way to know that this map is inaccurate. Okay, one more thing to do. To not do, I should say. We do not do contour maps with a ruler. Straight lines do not exist in real life, so we're not going to do it in labs or on any other exercise. It doesn't matter if your lines are a little bit crooked, that's the way the atmosphere is. And this map is a good representation of what's going on, but it's not accurate because the lines are not going to be perfect. Okay, so this map looks a little bit better and a little more accurate. To review, an isoline is a line on a map connecting all points of equal value. The interval is a numerical distance between the isolines. So in this case, our interval is 4 millibars. Okay, next we always draw smooth curved lines, and we extend the lines to the edges of the map or form closed paths when possible. Most important to remember that isolines do not cross each other. Very important. Let's not do this or points will be taken off. That's all for this lesson. Review your notes at home tonight. We are going to be practicing this more in class next week.